Okay, so last class we talked about choosing functions to model. And there were three different functions we could choose from. There was that y equals mx plus b, which is a straight line. There's exponential functions, which curves the asymptote. And there's the quadratic function, which either smiles or frowns. And we talked about how you can find these, which if you're given a set of numbers, by plotting them on a graph, you can find out which one it was. So today, we're going to look at how you can also determine if it's linear, exponential, or quadratic without graphing, without plotting it. And we're going to do that by showing you a way you can do it by doing some simple math. Okay. So before we do that, let's review these. What we took notes on last class. You don't need to take notes on these again. We already did. So we were talking about the three different types for linear. Remember, and then and at the very bottom of your notes, well, there's linear, exponential, and quadratic. And at the very bottom, I said there's a series in red. With linear says the first differences are constant. Exponential says the consecutive y values have a common ratio. And quadratic says the second differences are constant. And we really didn't delve much into that. And we're going to do that today, and we'll explain what that means. But you already do have notes on this. Let's see if I can get this a little closer. Okay. So kind of just what I just read to you. This is from the textbook. But it says you can use patterns between consecutive data pairs to determine which type of function models the data. The difference of consecutive y values is called the first differences. The differences of consecutive first differences are called second differences. Now that may seem confusing, but when I show you how to do it, it will make a little more sense. Okay. And you don't have to write down that either, but you do need to write down some examples. So tell whether each table of values represents a linear, exponential, or quadratic function. So again, we're looking at the differences here. So let's start with the x's. Do the x's have a constant rate of change? Well, yeah, you can see that it's increasing by 1 each time. So as x increases by 1, what's happening for y's as we go from one value to the next? Let's see here. 8 take away 11 would be a negative 3. 5 take away 8 would be a negative 3. 2 take away 5 would be a negative 3. A negative 1 take away 2 would be a negative 3. So we have a constant rate of change here. It's constant. And so if you have a constant rate of change at the top and a constant rate of change, meaning I just subtracted each time and I come up with the same number, constant rate of changes in the bottom, which one? It says the first differences are constant. This is the first differences, so that would be a linear. And if you were to graph this on a graph, it would be a straight line. Okay, let's look at the second one. X is increasing by how much each time? Looks like from negative 2 to negative 1, we increased by 1 again, keeping the math pretty simple. And every time we're increasing by 1. Okay, so it's a constant rate for the x. Now look at the y's. As we go from 1 to 2, it looks like we could be plusing 1, but then we go from 1 to 2 to 4. So we're not plusing 1, or so we'd have 3 next. Something else is happening here. If we go from 1 to 2, we actually multiplied it by 2. If we go 2 to 4, we multiply it by another 2. And from 4 to 8. So we're not adding each time, we're multiplying each time. So if we're multiplying each time, which one is that? So these consecutive y values do have a common ratio. So would that be, if it has a common ratio, would that be linear, exponential, or quadratic? Which one had the common ratio? Well, you can see under, I make this, I can do this, right? Exponential That's the one where it says consecutive y values have a common ratio. Remember, ratios deal with multiplication or division, not adding. So that one would be exponential. Okay, let's do this third one here. Notice in all of these, the x's are having a common, are increasing each time by the same value. There's a constant rate of change. So in this case, again, I think x is increasing by 1. It seems to be a popular theme. That's okay when we're learning something new. We want it pretty simple. So it doesn't look like we're multiplying because it goes -1, -2, -1. So if I were multiplying by the same number, it wouldn't be going up and down and up and down. And, you know, that couldn't happen. So we can rule out the multiplication. We know it's not exponential. It's not linear either because we're not decreasing by the same amount. So that would lead us to think it's exponential. I'm sorry, quadratic, right? But remember, to find quadratic, we need to find the second differences are constant. So what is this idea of second differences? Well, let's find the first difference first. So a -2 and a -1, if I were to subtract them, a -2, let's just write it out so you can see what I'm doing, minus a -1, but a negative and a negative is a positive. -2 plus 1 would equal a -1. So the first difference would be a -1. Okay, then let's do it again. A -1 minus a -2. What would that be? That would be a positive 1. And then what would the next one be? Well, a 2 minus a -1 would be a 3. And then a 7 minus a 2 would be 7 minus 2 is just a 5. So the first difference here isn't constant. If it was constant, it would be linear. But what we're looking for is the second difference. We're going to basically take these numbers and do it again and see what we get. So 1 minus a -1 would be a 2. 3 minus 1 would be a 2. 5 minus 3 would be a 2. And what we see is the second time we subtracted, we have a common number. And since the second round has a constant rate of change, that's what we would call a quadratic. And I should probably show what that would look like. The quadratic would either be a smiling or a frowning. But we don't know until we work it out, but what we do know is that it's quadratic. And exponential, I forgot to show what that would look like. It would look something like this. Okay, so those are the 3 options, and those how you find them. The first one you just find, is there a constant rate of change and a constant rate of change? If so, it's linear, straight. Is there a constant rate of change, and are you multiplying or dividing by a number? If so, it's exponential. Is there a constant rate of change, and then for the y's, is the second different constant? If so, it's quadratic. So that's how you can find out what these are without having to plot each point. So I don't think this is too tough of a concept. I would like you to go ahead and tell me which one of the 3 do you think this is. And if you need to rewind, feel free to rewind. Okay, try it again. One more time. Okay, last try. All right, before we end, moms. All right,